Hello and welcome to problem set number 5. Our topic today is writing chemical formulas for ionic compounds. And if you don't already have the worksheet printed out from my website, I would highly encourage you to pause and go do that really quickly. Otherwise, we're going to go ahead and get started. All right, so tons of practice with writing chemical formulas and names for ionic compounds today. Starting with number 1 here, we're going to write the formula, include the charge for the following ions. Hint, some are polyatomic ions. All right, so starting with calcium ion. So calcium, check its position in the periodic table. It is an alkaline earth metal in group 2A, so you can expect it to lose 2 electrons and attain a 2+ charge. Okay, a sodium ion. Sodium is an alkali metal in group 1A. It has 1 valence electron, so you can expect it to lose that 1 valence electron and obtain just a 1+ charge. Carbonate ion. Okay, carbonate, that ATE ending is a good indicator that it's probably a polyatomic ion. So if you don't have those memorized, you can always check your polyatomic ion chart, which I went ahead and left up here. That is from slide 7 of tutorial 5 notes. And then if you do have it memorized, that's great. CO3 2-. Okay, ammonium ion. That is one of the polyatomic ions that is a cation. So again, if you don't have those memorized, if you're still working on those, I highly recommend flashcards. Put the formula on one side, put the name on the other, then go ahead and look it up. But if you have it memorized, great. NH4 with a 1+ charge. Magnesium ion. Magnesium is in group 2A, so it's going to lose 2 electrons and form a 2+ charge. And hydroxide ion, that is one of your polyatomic ions, OH with a 1- charge. All right, going up to the top in the second column here, the nitride ion. Okay, nitrogen is in group 5A, so it's going to need to gain 3, it's a nonmetal, it's going to want to gain 3 electrons to complete its octet, so it's going to have a 3- charge. Now I purposely put nitrite ion below nitride to really point out to you that these are not the same. Nitrite is one of your polyatomic ions. Look it up if you need to. It's NO2 with a 1- charge. And then I also purposely put nitrate right below that, which is NO3 with a 1- charge. So nitride, I'm going to go ahead and write these. Nitrite and nitrate, they are not the same. The IDE ending here is a helpful hint that this is an atom that has gained electrons. The ITE and the ATE ending are good indicators here that you're talking about a polyatomic ion. And remember, the ite ending will always have fewer oxygen than your ate ending of the same prefix. Okay, so nitrite's going to have fewer oxygen than nitrate. So that kind of helps you with the memorization here. All right, sulfite ion. Again, a polyatomic ion, SO3 2-. Sulfide ions, I kind of did some tricky ones over here too. Sulfide, the IDE ending, indicates that that is an element, an atom of an element that has gained electrons. It's in group 6A, so it's going to gain 2. So a 2- charge for sulfide. And then sulfate is another polyatomic ion. It's going to have more oxygen than the sulfite. It's going to be SO4 with a 2- charge. Okay. All right, complete the table below by writing the formula for the ionic compound formed when the cation in the left column and the anion in the top row combine. See the example for further clarification. So I did a couple examples in there already. So let's erase number 1 and go on to number 2. Okay, so it's a chart. So let me go ahead and write the cations in here, which are already given. And then we're combining those with these anions. Okay, we're not naming them, we're just writing the formulas. So we'll do some naming below. All right, so I already did a couple of these. It's a 1-to-1 ratio, so this one's done for you already. Okay, let's just go ahead and fill them as we go down the columns here. So with calcium, it's a 2+ charge, combining with fluoride with a 1- charge. You can swap those numbers, or you can think of it more mathematically. It's going to take 2 fluorides, each with a 1- charge, to balance out the charge on just one calcium cation. So it's going to be a 1-to-2 ratio there. And the quickest way is just to switch the numbers, remember. All right, aluminum and fluoride. The aluminum cation has a 3+ charge. Fluoride is just 1-. So it's going to take 3 fluorides, each with a 1- charge, to balance out the charge on just one aluminum cation. So we're going to write that as 1 aluminum and 3 fluorides. Okay. And again, you can just switch these numbers, the 3 and the imaginary 1 here. So it takes 1 of these and 3 of these. That's the quickest way to do it. All right, here's a polyatomic cation, ammonium. It's got a 1+ charge. We're combining it with fluoride with a 1- charge. So it's a 1-to-1 ratio. So NH4 and F. You don't need any parentheses there because you're not trying to indicate that there's multiple of the ammoniums, just one. All right, let's move on to the second column here. So now we're combining the lithium cation with a sulfide anion. So sulfide has a 2- charge. It's going to take 2 lithium cations, each with a 1+ charge, to balance out just one sulfide. So we're going to write that as 2 lithiums to every 1 sulfide. 2 lithium cations to every 1 sulfide anion. All right, calcium is 2+, sulfide is 2-, so just a 1-to-1 ratio. CAS. And that's a good example of when that little switching rule, so I'm going to write these out, that little switching thing you do, of when you'd want to simplify. Okay, so you wouldn't want to leave it as 2-to-2, you'd want to simplify that to 1-to-1. Okay, so CAS. All right, aluminum, 3+, sulfide, 2-. So let's do the little switchy rule here. It's a good one to write it out for. Al3+, S with a 2-. We're going to make it a 3 over here. I'm going to make a 2 over here. So 2 aluminum cations for every 3 sulfide anions. Okay, so think about the charge there. Mathematically, that makes sense. 2 aluminums, each with a 3+ charge. That's going to be 6+. 3 sulfides, each with a 2- charge. 2- 3 times. It's going to be a 6-, and they're going to balance out to 0. Okay? All right, ammonium with a 1+ charge, sulfide with a 2- charge. It's going to take 2 ammonium, so we're going to need those parentheses when we're trying to say 2 NH4s. If you don't put the parenthesis there, it's going to look like you're saying 42 hydrogens to every 1 nitrogen, and that doesn't make sense for ammonium. So make sure you've got the parentheses, okay? And just 1 sulfide. So 2 ammonium cations to every 1 sulfide anion. Moving on to the third column here. It's going to take 3 lithium cations to balance out the charge on just 1 nitride anion. So Li3N. All right, with calcium and nitride, it's going to be 3 calciums to every 2 nitrides. So think about the charges there. I just did the little switchy rule, but what I'm really saying is 3 calciums with a 2+ charge, 3 calcium cations with a 2+ charge, that's a 6+, and 2 nitrides, each with a 3-, that's a 6-. Okay, so balances out 6+ and 6-. All right, aluminum has a 3+, nitride has a 3-, 1-to-1 ratio. Nice and easy that way. Looks kind of funny, but that's the answer. All right, and ammonium has a 1+ charge. Nitrite has a 3- charge. So it's going to take 3 ammoniums. You're going to need the parentheses here to balance out the charge on just one nitrite, anion. Last but not least, our last column here, lithium is a 1+, sulfite is a 2-. So it's going to take 2 lithiums for every 1 sulfite. Okay. Calcium is 2+, sulfite is 2-, so it's 1-to-1 ratio. And you don't need a parenthesis because you're not trying to indicate more than 1 sulfite. Aluminum is a 3+, sulfite is a 2-. So let's go ahead and do a little switchy rule here. Good practice. I'm going to take 3 of these and only 2 of these. So you're going to need the parentheses here, not on aluminum, but on the polyatomic ion, because you are trying to indicate that there are 3 of them. Not just 1, there's 3 of them. So parentheses 3. All right, last but not least, we're combining ammonium with sulfite. So a 1+ and a 2-. So it's going to take 2 ammoniums. So we're going to need the parentheses because we want to say the whole thing twice. 2 ammonium cations for every 1 sulfite anion. Okay, I'm going to erase all this and we're going to go on to number 3, where we're going to write the names for the ionic compounds. Write the names for the following ionic compounds. We've got MgS. Okay, so the cation is magnesium ion, and the anion is a sulfide, magnesium sulfide. Do not, under any circumstances, call this magnesium sulfur. Okay, it's magnesium sulfide. The sulfur has gained 2 electrons and become a sulfide anion. Okay, so reflect that in the name. All right, Libr. The cation is lithium, lithium ion. Okay, and the anion is bromide, IDE, not INE. Okay. KNO3. The cation is a potassium ion, so potassium. And use your periodic table. Okay, I'm not really doing that because I'm trying to go fast. I want to keep this short. And then NO3 is going to be hard until you've got those polyatomic ions memorized. So if you need to, look back to the polyatomic ion chart that I have in tutorial 5, slide 7. Hopefully you'll recognize NO3 as nitrate, potassium nitrate. Okay. And Al2O3. The cation is an aluminum ion, so we're going to start with aluminum. And the anion is oxide. Oxygen that has gained electrons, O with a 2- charge, is oxide. Again, really common mistake. People on an introductory chemistry exam are going to call that aluminum oxygen. Don't be the one to do that, please. Remember, this is an ionic compound. The oxygen has gained its electrons and become an oxide anion. So change the ending. All right, one more problem to go, and I think we better erase here because we're going to need the room. Okay, number 4. Last but not least, write the formula for the following ionic compounds. So we've got sodium, nitrite. I'm going to go ahead and write them all out first. We've got potassium sulfide. We've got barium chloride, aluminum oxide, ammonium hydroxide, and calcium hydroxide. Okay. And we'll leave the polyatomic ion chart up because it might be useful here. All right, so sodium nitrite. Sodium, check your periodic table. I don't expect anyone to have this memorized yet. So check the group number. It's a group 1A metal, so it's going to have a 1+ charge. Nitrite is a polyatomic anion, so if you need to look up its formula, do so. Okay, and you'll see that it has a 1- charge, so a 1+ and a 1-, they're going to balance out in a 1-to-1 ratio. So your formula is NaNO2 for sodium nitrite. All right, potassium sulfide. Potassium is a group 1A metal, so 1+ charge. Sulfide is a sulfur that has gained 2 electrons to complete its octet, so S with a 2- charge. So you can use a little switcheroo if you want here. It's going to take 2 potassiums to balance out the charge on 1 sulfide. All right, barium chloride. Barium is in group 2A, so we know that it is going to lose 2 electrons and obtain a 2+ charge. Chloride is one of the 7A elements. It's a halogen, so it has gained 1 electron to become a chloride anion. So it's going to take 2 chlorides to every 1 barium cation. Okay, so BaCl2. Aluminum oxide. Aluminum is a group 3A metal, so you can expect it to lose 3 electrons and obtain a 3+ charge. Oxygen is in group 6A, so it's going to need to gain 2 more electrons to become an oxide. So O with a 2- charge. So the switcheroo works really well here. The formula is going to be Al, 2 of them, O, 3 of them for aluminum oxide. All right, ammonium hydroxide. Ammonium is NH4 with a 1+ charge. It's a polyatomic ion, so if you need to look it up still, go ahead and look it up in the chart that I provided on slide 7 of tutorial 5. Hydroxide is also a polyatomic ion, OH with a 1- charge. So we're going to put these together in a 1-to-1 ratio. We don't need any parentheses because we're not trying to indicate more than one of either polyatomic ion. It's going to be NH4OH for ammonium hydroxide. Calcium hydroxide. Calcium is a group 2A metal. It's going to lose 2 electrons and obtain a 2+ charge. Hydroxide, we just saw before, is a polyatomic ion, OH with a 1- charge. So it's going to take 2 hydroxides to balance out the charge on just 1 calcium. Okay, so CaOH parentheses, because you're trying to say 2 of the polyatomic ions. Okay. If you didn't put the parentheses there, and I see this all the time in introductory chemistry classes, if you don't put the parentheses there, it looks like you've got 2 hydrogens and 1 oxygen, which is not the formula of a hydroxide. Hydroxide is an OH. You're trying to say that there are 2 OH 1-. Okay? All right, that concludes our problem set number 5. I hope you will consider tuning in to tutorial 6 as we continue learning how to name compounds. In the case of tutorial 6, that'll be molecular compounds. Thank you.